Good day, everyone. It's a joy to be here with you at the Learning Academy Foundation, where we believe that knowledge is not just power, it's purpose. Today, we are diving into the fascinating world of database development, a cornerstone of modern information systems. Whether you are managing a small business, building enterprise software, or organizing church records, databases are the silent engines driving efficiency, accuracy, and insight. Why databases are important? Through databases, you can manage large amounts of data. They are used to streamline operations and improve efficiency, analyze and make sense of data, security and data protection, sharing and data collaboration, centralized location for data storage, the structured data storage system, and data integration and interoperability. Let's start understanding the difference between relational database and flat file. A relational database is a type of database that organizes data into one or more tables, with each table consisting of a set of rows and columns. Each table has a unique key that can be used to establish relationships with other tables. Indeed, a flat file, on the other hand, is a simple file that contains a single table of data with no relationships between tables. Relational databases enforce data integrity through the use of primary and foreign keys, which ensures the data is stored in a consistent and accurate format, while flat files do not have any built-in mechanism for enforcing that integrity. Relational databases uses a relational data model, which is based on the mathematical concept of a relation. It's a high-level data model that provides a way to organize and manage data in a logical and consistent way, while flat files use a flat data model, which is a simple data model that stores data in a single table with no relationships. Relational databases provide a variety of data access methods, including SQL, which allows for complex queries and data manipulation, while flat files can only be accessed and manipulated through simple file input-output operations. Relational databases are optimized for performance with indexes, caching, and other techniques to improve query speed, while flat files, on the other hand, can be slow when dealing with large datasets and complex queries. Finally, relational databases can handle large amounts of data and handle the concurrent access from multiple users, while flat files are not designed to handle large amounts of data and are not well suited for concurrent access. So let's start with the basics. Flat file databases are simple, single table systems. Think of a spreadsheet with rows and columns. They are ready to set up, but quickly become inefficient as data grows. Imagine storing all your contacts, invoices, and inventory in a one giant table. Chaos, right? Relational databases, on the other hand, are structured to handle complexity. They store data in multiple related tables, reducing redundancy and improving integrity. Systems like MySQL, PostgreSQL, and Microsoft Access fall into this category. They are the backbone of scalable, secure data management. To design a relational database, we use entity relationship diagrams to map out how data entities relate to one another. One-to-one. Each record in table A relates to one record in table B. Example, a person and their passport. Or an employer in its name, its age, its store, salary, and so on. The rows are called records. The columns are the groups. stores specific data type, like name, number. And then one to many or many to one. A single record in table A relates to many in table B. For example, one teacher teaches many students. And then many to many records in table A relates to many in table B and vice versa. So it's a join between two tables, each containing 1,000 records will result to 1 million combination from this join. For example, for you mathematicians, the result is a Cartesian product. So this is the result of every record in table A relates to every record in table B, and every record in table B relates to every record in table A. Example, students enrolled in multiple courses. These relationships help us build databases that mirror real-world interactions. Let's talk about queries. So asking the right questions. Once your data is structured, you need to retrieve it. That's where queries come in. Query by example. I use a friend, the method where you fill out a form to define your search criteria. Complex queries. For example, and query or query. And query finds records that must match all criteria specified, so matching all conditions, or query finds records that can match one or more conditions, so finds records matching any conditions. So for example, in this picture, we can have look at picture that is green, has green in it, and ice. Okay, it means they are both. Or look at the picture that has hair and eyes or ears. So it still means only the boy on the girl on the right. And then we have not query, excludes records with certain criteria, and calculated query performs operations like totals, averages, or custom formulas. Query transform raw data into meaningful insights. So from archived live streaming data to descriptive, predictive, diagnostic, prescriptive analytics through AI algorithms into actionable insights. Okay, let's talk about reports, main merges, and macros. What are they? Reports. These are formatted outputs of query results, perfect for printing, sharing, or presenting. Whether it's a monthly sales summary or a list of prayer requests, reports make data digestible. We start from the big query designer tool, info provider, and then through query definition. From this, we go to the query results in forms of workbook. The formatted results of workbook will be formatted workbook, while query results, for example, web browser, the formatted results will be reports. Formatted web report or presentation quality report. And then main merge. This feature links your database to a document template, allowing you to personalize letters, emails, or certificates. Imagine sending customized invitations to every member of your congregation automatically. So reports, merge, and macros. These are automated sequences that perform repetitive tasks. Want to generate a report, email it, and archive it all with one click? Macros make it happen. How artificial intelligence automates repetitive tasks across industries. Through AI in finance, in customer service, in logistics, in human resources, and in healthcare. What are the advantages of macros? Save time, reduce human error, improve consistency, and empower non-technical users. There are 7 benefits for short-term goals. These are clarity and focus, flexibility, accountability, increased productivity, motivation, time management, and tangible results. In Genesis, God brings order out of chaos. In many ways, database development mirrors that divine act, bringing structure, clarity, and purpose to scattered information. As steward of knowledge, and knowledge is power, we are called to manage resources wisely. Databases help us do just that, whether it's organizing church ministries, tracking donations, or supporting community outreach. Let us remember Colossians 3:23. Whatever you do, work heartily. It means work at it with all your heart, as working for the Lord and not for man. Even in the realm of data, our work can be an act of worship. We do it this day by day, step by step. If this message inspired you or you learned something new today, I invite you to like, comment, share, and subscribe to Learning Academy Foundation. Together we make the future. Let's build systems that serve people, glorify God, and transform communities. Thank you, and God bless you all. Bye.